Good morning, everybody. Welcome to today's session on the Trimble UX5 and the FAA Exemption 333. I do appreciate everybody taking the time to attend our webinar this morning. This is just going to be an informative webinar on what this FAA exemption on the Trimble UX5 means for us and for our customers. Before we get started, a couple of housekeeping notes that I will give you. In the GoToWebinar interface, there is a chat window. If you have attended our webinars in the past, we just prefer that you ask questions in the chat window. We'll answer them at the end of the session. I do have another panelist or two on today to help me with some of the technical details because I may not be the expert. If we can't answer your question, we will certainly get back to you on it. Additionally, we will record today's session, and that will be issued for playback here shortly within the next few days, and we will post that on our blog site, either on the fpisurvey.com blog site as well as the fpimapping.com blog site. So before we get started, I think it's important for us to state that we feel very strongly that Trimble is dedicated to doing this process right, and that is flying UAS legally, making sure that we and our customers operate UAS responsibly and within the guidelines of the FAA. That's one thing that's important to us, and we want to make sure that that's stated before we get started here. So the agenda today, if we review that, is to review the UAS applications and their benefits. We'll take a look at that Trimble Exemption 333. We'll also look at an Exemption 333 derivative that ourselves are undertaking, that being Frontier Precision, and our customers can undertake as well if they wish. And then we will look at how that impacts potential uses and users in the field. And then there's always things changing regarding UAS flight status, so we'll try to give the latest and greatest FAA status as it relates to fixed-wing aircraft, and as well as even other aircraft, rotor aircraft, things like that. All right, so before we begin, let's just take a look at reviewing some of the applications and benefits of the aerial imaging solutions. We kind of break those down into 5 different parts. There's economic solutions, which basically takes this technology and reserves it for some of the larger engineering and surveying firms to be used by the masses, essentially utilizing this technology to cover larger areas, do larger corridor type surveys, things like that. There's obviously a safety benefit in that you're staying out of harm's way. You can fly over a busy intersection without going into the intersection, for instance. You can do a volume computation on a coal pile without having to get on the pile, things like that. There's also efficient processes. It's very simple to fly these, even though the restrictions on flight are very, very important. It's very simple to fly these. You can collect the data really fast, process the data, bring the images together. The workflow is very rapid, and obviously it makes the system very versatile for the user base. So we've just identified a few target markets that this is being used in today, or looking at being used. Obviously, with the FAA restrictions that we have in the United States, there's not a lot of people flying these in the U.S., but in Canada, in South America, in other countries, this is being used a lot in these markets, whether it's engineering, surveying, mining, construction, but even public agencies for environmental type work, landfills, agriculture, and forestry is also a big one. So if we break those down into what types of surveys are being done, you can see boundary surveys, topo surveys, site planning, obviously transportation and route planning for oil and gas, progress monitoring, as-builts. There's also a mapping component that's being used. I spoke to the point of volume calculations. and then obviously disaster analysis, hurricanes, floods, things like that, and then ag market is using this for vegetation health. So we'll take a look at each one of these here briefly. So if we look at boundary surveys or topographic surveys, where we have a large area to be surveyed, a lot of interest to be done. Maybe there's some high traffic areas, things like that. You can see the reduced time and costs, more accurate representation of the topography. And so here's an example. A lot of these will be in other countries, but this was in Switzerland where they did 510 images. They flew at 400 meters. As you notice, 400 meters, they only got 11 centimeter standard deviation over that large area. If we look at a site planning or a route planning type of survey, again, a lot of interest. Access to roads maybe is an issue. They want to get drill rig pads, structures, drainage areas, as well as map out those roads and structures and fences and things like that. And so you can see in this particular example, this happens to be in Belgium. They flew a little bit lower, 150 meters, and they were able to achieve a 5 centimeter standard deviation. 462 images, I'm sorry, not flights, and you can see that route planning was pretty easily done within this environment based on the imagery. If we look at another application like progress monitoring, you can see that some of the problems with that is the current overview of the site is typically the issue. Traditional methods are often interrupted by other operations that are going on. So eliminating time and costs associated with having to send crews out multiple times or get data that isn't particularly easily to capture with other methods. So you can see this progress monitoring on the left, the start of the project, and as the project takes shape, flying it several times and looking at the progress. In this particular instance, again, flying only 150 meters, able to achieve 5.7 centimeters of standard deviation. And then we'll take a look at a couple of more applications that seem to be of interest. Volume calculations where large areas are to be surveyed, could be hazardous, and other data collection devices may be slow or even overkill at times. So here's an open pit mine example, 640 images, 150 meter flight height with about a 5.5 centimeter standard deviation. Resource mapping, as-builting. So again, very similar to some of the other applications where it's a large survey. A lot of things need to be mapped in a short period of time. Other methods may be slow compared to this method. You can see here with 288 images, they're able to achieve 5 centimeter standard deviation at 100 meters of flight height. And obviously the ag market with vegetation health, being able to use a different type of camera device to monitor vegetation health. So you can see here this is a normalized vegetation index type of solution where they were able to again fly at 100 meters with 5 centimeter standard deviation. Okay, so all of that would be fantastic if we were able to just launch one of these babies and go to town, but it's unfortunately not that easy in regards to flying UAS. So we want to just cover for a brief moment the pathways to legal flight for UAS type of devices and what those legal flight operations look like. So if we break down excuse me, legal flight operations as they relate to certificate of waiver or authorization. We refer to that as a COA. A lot of times you will hear us talk about COAs quite a bit, as well as there's some things in regards to the airworthiness, certificate, the SAC, and that is regarding the particular aircraft. As the UX5 is related, it has to have some certificate of airworthiness to be able to fly. So there's a serial number and a defined location where that particular device can fly, how high it can fly, things like that. And then there's this new FAA Modernization Reform Act 2012 Section 333 exemption, which is what we're going to talk about a little bit more here today. That is reserved for civil operators, not necessarily public entities that are under the traditional COA method. So civil operators can actually use this particular exemption to fly without being a public agency or flying under a public agency previously defined COA. And that, again, includes an aircraft and what that model aircraft is. Potentially it has a little bit more flexibility on location, but it's approved and administered by the FAA. So key requirements that we've identified for COAs. Traditionally, COAs in the past have been reserved for public entities like universities, law enforcement, DOTs, cities, counties, other state agencies, federal agencies. The aircraft must be owned by the department. Airworthiness is required. Certificate is required. The operator has to go through ground school training, passing a Class G airspace grade, and the observer and pilot must each have a current Class 2 medical certificate. The airspace is controlled or uncontrolled, but cannot be Class B airspace, and it's determined by basically agreement among flight standards and air traffic control. So there's quite a few restrictions in regards to the operation of the COA. SACs are manufacturer specific typically. They're an experimental category for non-type aircraft. The aircraft requires a FAA registration, and the airworthiness of the aircraft is approved by FAA. For instance, with the Trimble UX5, Trimble had to go out to Washington, D.C., fly that in front of the FAA, and go through approvals for their SAC for that particular aircraft. Again, it is a private pilot's license, and second class medical certificate is required, and the observer and pilot both, again, must have that second class medical certificate. The key requirements for Section 333, again, the big identifier here or difference is that it's more of a civil proponent. So traditional engineering, surveying, mining firms that are companies could apply for a Section 333 or fly under that particular section certificate. No clear requirement on aircraft ownership, and the ownership of the aircraft worthiness is currently unknown as it relates to Section 333. The operator may be used for hire, basically for hire work, and the exemption can be requested by the end user. There's really no clear restriction on airspace, but it's expected to be limited to Class C, D, E, and G, but might not be an option. Not all those would be an option for Trimble aircraft. So how does this apply relative to the UX5 in regards to the certificate of operation and the Section 333 exemption? So really on the traditional COA application process, nothing has changed there. Public agencies can still apply for a COA, and based on that COA being granted by the FAA, they can purchase at any time a UX5. So that really hasn't changed. When it comes to the Section 333 exemption, that currently, as Trimble's exemption is was being sought and now approved, applies only to the UX5, which, like I had noted earlier, has the airworthiness certificate. The Section 333 exemption does require, though, that it is a Trimble-operated aircraft. So it doesn't mean that since Trimble received a Section 333 exemption that anybody now can just purchase a UX5. It doesn't work like that. It is Trimble operational only. And the operator under this exemption must be a licensed pilot. And it is a two-man operation. That pilot is on site, and there's also an observer to observe the aircraft while it's in flight. And there are other restrictions, but the biggest ones being the ones that are noted here. So like I had mentioned, the exemption does not allow Frontier Precision or any other customers to just pick up one of these UX5s and fly it. It is a Trimble flight requirement only. And the initial stages of that Section 333 were to use for demonstration and testing. When you get approved for Section 333, you still need to apply for a certificate of authorization for each site that you want to fly. You can't just, now that you've been approved for Section 333, you can't just fly it anywhere you want. You still have to go through a COA process with the FAA to approve it to be flown in a particular area of interest. Traditionally, these COAs then are granted a lot faster than they are if a public agency just applies for one. Since the 333 has been granted, the COA process should be a lot smoother and a lot faster. So where does that leave us as users? It still doesn't give us a lot of opportunity to fly the UX5. So with some of the things that we've been talking to Trimble about to get this flight out there with other users or users that have applications that want to use the UX5, we've come up with a couple of options for our customers to fly it under this umbrella, so to speak. So again, with these two options, it does require Trimble to fly the aircraft. So the first option is a Trimble controlled flight where a COA is required. We identify a site with a customer. We apply for that exemption, COA, under the exemption for that particular area of interest. It gets approved, and then Trimble can come out and do the service. Or a more in-depth professional service agreement can be done with Trimble and the customer. Again, a COA is required, but Trimble can assist with that COA in either one of those two options. So if you look at option one, that's a flat rate project, more of a turnkey project. Again, a COA is required, but Trimble personnel can travel the site with a pilot. And they're going to charge you $2,500 travel charge per day for that particular pilot and travel charges, depending on, obviously, if it's in a foreign country, that's not necessarily going to be the case, but anywhere within the U.S. for sure. Fly the project, 2-day minimum. They process the data for you and provide the deliverables. So that would be one option. The other option we've identified is a custom service where they may require more than 2 days of work. So a professional services agreement may be needed to be drawn up. We define a statement of work, and the cost is going to be based on that statement of work. And in this case, the customer may also purchase a software, whether it's a Trimble Business Center photogrammetry option, or it's UAS Master software, and they will process their own data set. Again, a COA is required for this type of project and this service. The only thing Trimble may be doing in this particular case is flying the aircraft. One other thing that's going on, and something that we've undertaken, and certainly our customers can do so as well, is what we're kind of calling a Section 333 derivative. And with that, we're in the process of applying for our own 333 derivative and using the same parameters as Trimble applied for. And we would be able to then apply those services on a more regional basis, just as we discussed in option 1 and 2, where Trimble was doing that before. Frontier would provide those. And obviously we would stay within the FAA requirements on that. So that's in the process now. So we talked briefly about the COA and where that kind of fits in. The airworthiness certificate and the UX5 does fall within that classification. It's been certified by the FAA. Where that Section 333 may fall in with users. And then we do want to just discuss briefly here what new information is out there. The latest thing that has been put out there by the FAA was on on February 15th of this year. They issued a press release and basically they proposed new rules for small UAS devices. And I'm sure a lot of you saw some publicity about that. It was broadcast by Professional Surveyor magazine and their e-newsletter, and XYZHT magazine, or whatever that's called now, XYHT. It was also publicized in their newsletter, so you might have seen something about it. So we took that and we kind of broke it down with some of the important aspects of what they're proposing. Now again, this is just a proposal. The FAA now currently has this out for public comment. That period will last at least 60 days, I'm thinking, is what I remember seeing. And then after that, then they will potentially put this into a rule and how they're going to classify these small aircrafts for commercial use. This could still take quite a long time, whether it's 6 months to a year. I would anticipate at least that long. So it is not something that is going to happen here soon. So again, this is just a proposal by the FAA. So we've highlighted a few things that are important in red. Visual line of sight is going to be a requirement based on this provision. The aircraft cannot operate over any people that are not directly involved with the operation. So you can't fly over living quarters of someone unless they are directly involved with this particular flight. You can't fly at night. Obviously we have to yield to other aircraft, manned or unmanned aircraft. Maximum airspeed is 100 miles an hour. Maximum altitude of the UX5 would be 500 feet based on this proposal. No careless or reckless operation. Pre-flight inspection, which is required now, it would still be required. And operators would have to pass an initial aeronautical knowledge test that is approved by the FAA and vetted by the Transportation Security Administration. So nowhere in here did you see that you have to be a private pilot. So they are proposing that you do not have to be a private pilot, but pass an aeronautical knowledge test by the FAA, that's approved by the FAA. And you still would require, or at least it's being proposed that you may be required to have a medical certificate of some sort, but that remains to be seen. But the big one is the pilot license, not necessarily being a requirement going forward, just passing a test, and that test is put on by the FAA, not by Trimble or any other manufacturer. So a few questions that it creates, obviously. What are people saying about these proposed rules? How can I prepare myself? Where do I get more information? Can I ask a question or submit feedback in regards to this proposal? So you can go anywhere on the web and do any of this. There's a ton of information out there. Google is your best source. You can see just a couple of related articles here just in the last couple of weeks. There's an Unmanned Systems conference coming up in May. You can also attend. That's in Atlanta. So things like that, there's all kinds of information out there, and you can Google search and get up to speed on some of this stuff. These are some of the things that we just discussed here a little bit. This COA as it relates to unmanned aircraft systems, the airworthiness certificate of unmanned aircraft systems, the Section 333, and then FAA's got an article on their website in regards to busting myths about the FAA and UAS. It's also a very good publication read that you can go to. So with that, just want to point out some of our goals as it relates to this, because we're getting a lot of questions about flying these devices. So we've come up with these options. Obviously want to spread the information in regards to truly what that Section 333 means. But at the end of the day, we want to give our customers an avenue to use the UAS as a solution. With that, we want to follow the rules and guidelines of the FAA, provide expertise and assistance as it relates to that, and then eventually allow our customers to perform UAS projects on their own. That is our goal. Okay, so here's our contact information if you need more information on some of these rules and options as it relates to the UX5 and the Section 333. With that, I will leave this up here, and I will now look and see what we have for questions. So one of the questions was, can a tribal organization apply for a COA? And they are considered certainly a federal organization, so they could certainly apply for a COA as far as I understand. Another question, what may be the timeline for applying for the exemption and also for a site permit? That really varies. If you apply for your own exemption, 333, and not follow the Trimble exemption, it could be, I think they applied for theirs last year in May and it was granted in December, so 6 to 8 months. If you apply under the Trimble using the same guidelines as Trimble used, and you can apply for that derivative as we called it, you just need to get in touch with one of us and we will help you with that. And they're telling us anywhere from 4 to 6 months, so it does take a little bit of time. And then the next question, hopefully that answered that one. The next question is, what does it mean to be vetted by TSA? I'm not sure that TSA really is involved with this. It's more the working directly with the FAA. The FAA is the one that is fielding all the calls. And the one thing that you got to understand here is that they are getting a lot of pressure to figure something out. It's not that the FAA is trying to make it difficult for us to fly this, but you got to understand that it's important for them to issue rules and regulations as it relates to safe flying. So that's what they're interested in, but they also have a lot of pressure to get this done. So they want to get this out and done and have rules in place that people can abide by and that are realistic. As much as anyone. So I would say that we don't want to encourage people to just go out and start flying, because when they do that, bad things happen, and that's only going to delay the process. For instance, a few weeks back, somebody flew a UAS device and landed it in the White House lawn. Quite honestly, that did not help this process. So those types of things we want to try to stay away from, because it's only going to make this a longer process. It's only going to make potentially the regulations more stringent. So I do not encourage anyone to just go out and start flying these around without getting FAA approval. Those are the questions I saw. Again, if there are no other questions, as a reminder, we are recording this session. We will have it available for playback, so you will be able to get it if you subscribe to our blog. We'll send a notification out later on this week when it's available for playback, as well as it'll be put on our FPI blog site, and for the survey customers, that's fpisurvey.com, and for our mapping customers, it's fpimapping.com. So again, I thank everyone for their attention today, and with that, unless there are any other questions, we will end today's webinar. Thank you.